Okay, in this video, we're going to use something called the Law of Cosines to solve non-right triangles. Now remember that a non-right triangle is a triangle that is not a right triangle, right? Which means that it doesn't have a 90-degree angle in it. And remember, there are two types of non-right triangles. The first type is an acute triangle, where every single angle is less than 90 degrees. And the second type is an obtuse triangle, where there is one angle that is greater than 90 degrees, which will, this one case, it's B, and which means that the other two have to be smaller acute triangles. Now, the law of cosines actually says this, that if you want to find the side of any non-right triangle, so in this case, let's just take C, you can do c squared is equal to a squared plus b squared. That sounds like the Pythagorean theorem, doesn't it? And it is so far. But c squared, you can find any of these sides. C squared is equal to a squared plus b squared minus 2 times the two sides over here. Now, so not the side you're trying to find, but these two sides, 2 times a times b, times the cosine opposite the side you're trying to find. So cosine C. So notice that A and B are determined by these two, and the missing one is determined by this over here. Okay, the angle is determined by the side you're trying to find. Now let's say you're trying to find side B. Okay, in the same way you would say B squared is equal to A squared plus C squared minus 2 times these two sides, A times C, times the cosine of the missing side, opposite the missing angle of the missing side you're looking for. Okay, so cosine B. So again, A, B, C, and then this side would just be those two. And finally, let's just solve for A. A squared would be equal to, so this side would be equal to this squared plus this squared minus 2BC times the cosine of A. Okay? Now let's try this with a real-life problem and see what we can come up with. And here's an example. So let's say I am trying to solve for this. Actually, let me move it down just a teeny bit. Sorry, I missed that. There we go. Let's say I'm trying to find I'm solving for this this triangle here, okay, this non-right triangle. So I need to find angle A, angle B, and side C. So let's start by trying to find side C. Now, according to my formula, the law of cosines, I would have to say that C squared is equal to A squared plus B squared, A squared plus B squared, minus 2 times A times B, times the cosine of angle C. Okay? Now we can actually fill in most of that. So what I get is step 1, step 2. C squared is equal to 10 squared plus 22 squared minus 2 times A times B times the cosine of 28. Okay, and the cosine of 28, just real quickly, is equal to cosine 28, 0.883. Okay, now remember your PEMDAS. Do the exponents first, so this is going to be equal to 100. 22 times 22 is equal to 484. Do the multiplication now, so I get 20 times 22, and that's equal to 440 times 0.883. Okay, let's continue. let me just make this a little bit bigger. There we go. So 440, remember you got to do PEMDAS again, and you always do the multiplication before the additions and subtractions. So 440 times 0.883 gives me 3. Let me just write all the rest of these in. Let me add those two together. And that's 388 rather, 0.5. That gives me c squared is equal to 195.5. Okay, let me just, again, make this a little bit better. Take the square root of both sides, and I get the square root of 195.5 is equal to 14. 13.982, but we're going to round it to 14. So we've now solved for one of the missing sides, okay? Let me just go ahead and put that up there. Now we need to solve for the obtuse angle and for the acute angle. Now I'm going to suggest that you always solve for the acute angle first, and I'll tell you why after we have solved this, okay? So let's solve for the acute angle. So let's say find angle A. All right, and again, let's think how we can do this. So now that I know that 3 sides plus one of the angles, I can go back to using the law of sines, which are just my proportions, right? Because I know enough now to find just one variable, which is just that. So this is what I'm going to say. I'm going to say that sine of angle A over its length, 10, is proportionate to the side of sine rather of 28 degrees, sine C, over its length, what we just determined to be 14. All right, so let's see, and we only have one variable now, and that's going to be angle A. So let's go ahead and solve this. We know that the sine of 28, according to our calculator, is 0.469. And I got sine A over here times 10. If I do some cross products, well, actually, I'm just going to multiply this side by 10. I'm going to get 4.69 divided by 14 will be equal to sine A. Again, let's just make it so we have enough room. So 4.69 divided by 14 gives me sine A is equal to 0.335. Now remember, when you need to find an angle, you're going to use the inverse of the sine. So I'm going to multiply both sides by the inverse sine, which is just given like this. Inverse sine times 0.335. Remember that when you multiply something by its inverse, sine times its inverse, it cancels to 1. So you're going to end up with angle A is equal to the inverse sine of 0.335. Let's go ahead and put that in here. So inverse sine, 0.335, 19.6 degrees. Okay, so let's go ahead and fill that in. Now I have 19.6 degrees. Now to find the obtuse angle B, so let's just say to find angle B, I just used the theorem, the postulate really, that the internal angles of a triangle add up to 180. So I'm going to get 19.6 degrees plus angle B plus 28 degrees should be equal to 180 degrees. Let's go ahead and add up 19.6 plus 28. That gives me 47. 47.6. Subtract that from 180, and I'm going to end up with 132. Let me see. Again, make this a little bit smaller so I can get everything in there. There we go. Angle B is equal to 132.4 degrees, and I've now solved. And it makes sense because this is clearly an obtuse angle. So 132.4 degrees. Okay. Now, let me give you a caution. If you would have solved for B, all right, angle B, and then over here I would put sine B over 22 is equal to sine 28 over 14. It looks like I could have done that, couldn't I? You would have gotten for an answer 47.6. Now, the signs work for finding angles that are less than 90 degrees. When it's over, like 100, when it's over 90 degrees, like this obtuse angle, you always have to add 90 to that, and that would have gotten you to the 132. Okay? You'll see what I mean if you actually try this, but good luck to you. Remember, always solve for the two acute angles first, and then find the obtuse angle next. Okay, hope that was helpful.